Hello students, welcome to the second lecture of Basic Electrical Engineering JNTU first year. In the first lecture, we discussed unit number 1 BEE DC circuits, first part of the first unit, that is Introduction to Electrical Engineering. And in this lecture, we will discuss the JNTU previous bit paper questions and solutions of topic called series circuit and parallel circuit. So this second part of the first unit I am calling as network analysis. In the network analysis, we will discuss about the whenever series circuit or parallel circuit is given with the DC excitation. DC excitation means DC input power. Then we will analyze the circuit. So let us start with the first question. A circuit having neither any energy source nor any EMF source is called dash circuit. It means circuit is not having any energy source. Energy source is not there in the circuit, and EMF source is not there in the circuit. So whenever there is no energy source, no EMF source, that kind of circuit we call as a passive circuit. So whenever at least one energy source is there, then we'll be calling as an active circuit. But here no energy source is there, no EMF source is there, then we call as a passive circuit. So answer is C. Next, let us go to the second question. In mesh current method of network analysis, what is the independent variable? So in mesh current method, mesh current is the independent variable. So we use mesh analysis, we use a nodal analysis. So in that mesh analysis method, we use a mesh current as a independent variable. Let us go to the third question. Two resistors of 12 ohm and 4 ohm are respectively connected in series. So how they are connected? Two resistors 12 ohm and 4 ohm. How they are connected? They are connected in series connection. A short is placed across the combination. So short circuit is placed across the combination. Then what is the effective resistance? Effective resistance means we call this as equivalent resistance, or we can also call as total resistance. So what here it is told is, let us say first this is 12 ohm, and here one more resistor 4 ohm. Both are connected in series. Let us say I have connected one DC supply here. Some DC supply I have connected. Then a short nothing but here short circuit. Short circuit is nothing but 0 ohm resistance is placed across the combination. So this is a series combination. Across means parallel connection. You see, across means here this is the parallel connection. In parallel, what is placed? Short circuit is placed. Short circuit is nothing but how much resistance? 0 ohm resistance. Now what is the total resistance? You see, whenever anything is connected in parallel with the short circuit, this entire thing will be neglected, because total current will be flowing through short circuit only. Whatever current coming here, that entire current will be flowing through short circuit only. No current will be flowing through this particular branch of the circuit, because current always prefers to go in the low resistance path. As entire current is going through the short circuit, this entire combination becomes redundant, that means useless. No current will be flowing here. So then this part I can neglect. Means, so what is the new circuit now? This is a new circuit. This is short circuit. Short circuit is nothing but how much ohm? 0 ohm. So what is the effective resistance? That is 0 ohm. Always remember, if anything is connected across the short circuit, if anything is connected in parallel with the short circuit, that thing which is connected in parallel with the short circuit will be entirely neglected. So in this manner, straight away we can tell equivalent resistance answer is short circuit, that is 0 ohm. In one more manner also, let us see. So this is the let us say this is a DC power supply, and here 12 ohm and here 4 ohm are connected in series. Across this combination, across nothing but parallel. So this parallel, what is connected? This is short circuit. This is short circuit. Short circuit is nothing but what? How much resistance it is? 0 ohm. Then what is the total resistance? Total resistance means with this power supply, with this power supply terminals, what resistance is going to be finally remained. See, 12 ohm and 4 ohm, these two are connected in series. Then as R1 and R2 are connected in series, equivalent resistance is R1 plus R2, that is 16 ohm. Then you replace the circuit like this. This is the battery, no change in the battery. Here I got 16 ohm resistance and here I got a short circuit. So short circuit nothing but how much resistance? 0 ohm. Now you see the 16 ohm see, this is the power supply, and here we got previously 16 ohm resistance. Here we got short circuit. Short circuit nothing but 0 ohm. Now 16 ohm, 0 ohm, both the resistors first ends are connected at one common point. 16 ohm and 0 ohm, both the resistors second ends are connected at other common point. This connection is known as what connection? Parallel connection. Now let us say this is R1 and it is R2. R1 and R2 are connected in parallel. What is the total resistance or effective resistance formula? R1 R2 by R1 plus R2, that is 16 into 0 divided by 16 plus 0. So what is the answer? 0. So these two resistors parallel combination is replaced with how much resistance? 0 ohm. Now you see, this is the battery and here I am getting 0 ohm. 0 ohm is nothing but what? Short circuit. So finally with the battery terminals, what resistance is connected? 0 ohm is connected. Answer is D. Effective resistance or total resistance or equivalent resistance is nothing but what? D. 0 ohm. Let us go with the next question. Two resistances R1 and R2 are connected in series. What is the equivalent resistance? As we all know, whenever two resistors are connected in series, the total resistance is going to be R1 plus R2. Answer is A. Whenever two resistors are connected in parallel, what is the total resistance formula? 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. This is a parallel connection formula. This is parallel connection formula. Let us say only two resistors are there. Then 1 by R total is equal to 1 by R1 plus 1 by R2. Then if I calculate R total value, what is the formula? R1 R2 divided by R1 plus R2. And one small important thing you remember, let us say there are four resistors are there. Four resistors are there. Each resistance value is capital R. Then all four are connected in parallel connection. Then what is the total resistance formula? One small formula you remember, whenever equal resistances R ohm, R ohm, R ohm, R ohm, like that 4 R ohm resistors are connected in parallel. 4 equal resistors are connected in parallel. Each resistance value is R. Then total resistance formula is that resistance value divided by number of resistors. Resistance value is R. Number of resistors, how many are connected? 4 connected. So this is a formula, important formula, R by N. Next question. 4 resistors. How many resistors are there? N is equal to 4. Each of resistance R ohm. You see, each of resistance R ohm means all are equal resistors. Equal resistors, how many are there? 4. The minimum resistance of the combination. Those 4 resistors, whether you want to connect it in parallel, whether you want to connect it in series, whether you want to connect it in series parallel, but in which combination we are going to get the minimum resistance of that particular combination. See, usually whenever R1, R2, R3, R4 are connected in series, total resistance is R1 plus R2 plus R3 plus R4. Whenever resistors are connected in series, total resistance, the combination, the combination resistance is going to increase, large value we will get. Whenever resistors are connected in parallel, we will get the least total resistance. So to get the minimum resistance of the combination, all the four resistors must be connected in parallel like this: R1, R2, R3, R4. So each resistor value is how much? R, 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 R. All are connected in parallel. Then what is the total resistance? Total resistance is resistance value by number of resistors. Resistance value is R. How many resistors are there? Total 4 resistors are there. So minimum combination is R by 4. The minimum resistance of the combination, whenever they are connected in parallel, we will get the minimum resistance, that is R by 4. Answer is C. Next, sixth question, it's about the mutual inductance. So mutual inductance is represented by the watt symbol. So mutual inductance is represented by the M. L is the self inductance. K is the coefficient of coupling between the two coils. So mutual inductance we represent with M, and its units are nothing but what? Like self inductance also, units are nothing but what? Henry. Next, seventh question, it's about again two coils coupling or mutual inductance. The coupling between the two magnetically coupled coils is said to be ideal if the coefficient of coupling K is how much? You see, this is the coil 1. Let us say coil 1 self inductance is L1, and this is a coil 2 and its self inductance is L2. Both are magnetically coupled, so they have mutual inductance M between the two coils. Then mutual inductance M is equal to, what is the formula is? K root L1 L2. So whatever the flux developed in the coil 1, if entirely linking with the coil 2, so total flux developed in the coil 1 is entirely linking with the coil 2, then we say coupling is ideal. Then coefficient of coupling K value will be 1. So let us say the flux developed in the coil 1, out of this total flux only 50% is linked with the coil 2, then coefficient of coupling K value is become 0.5. 0.5 or we say 50%. Ideal means we say 100%. So what here it is asked? The coupling between two magnetically coupled coils is said to be ideal. Ideal nothing but, so whatever the flux developed in the coil 1 has to be entirely should be linked with the coil 2. Then coefficient of coupling should be 1 or it is 100%. So 1, that is answer is D. Next, question number 8. Again it's about the mutual inductance or coupling coefficient. The two coupled coils with L1 L2 equal 0.6. So L1 value, L2 value, how much it is given? 0.6. Have a coupling coefficient of 0.8. So K value is 0.8 or 80%. Then turns ratio is asking N1 by N2 value is equal to how much? So we have one formula, that is inductance is equal to N square divided by reluctance. Reluctance is nothing but it's like a resistance. Resistance opposes a flow of current. Reluctance opposes a development of the flux. It opposes a flux. So from this what we can write? L proportional to N square we can write. So here what it is asked? N1 by N2 value is asked. So L1 proportional to N1 square. Similarly I can write here L1 proportional to N1 square, L2 proportional to N2 square. Then I want N1 by N2 value. Then I'll write like this: N1 square by N2 square is equal to L1 divided by L2. But I want only N1 by N2 value. So N1 by N2 is equal to root of L1 by L2. So n1 by n2 is equal to root of L1 by L2, that is 0.6 divided by 0.6, that is equal to what is the value? 1. So the turns ratio n1 by n2 value is 1. Answer is D. Next question. Let us start with the ninth question. Three capacitors. It's about the capacitors connection. Three capacitors. C1 is equal to 2 microfarad. Micro means 10 power minus 6. C2 is 4 microfarad. And C3 is 8 microfarad. C3 is 8 microfarad. They are connected in parallel. So they are, how they are connected? Parallel. So this symbol I am using for parallel connection. And their equivalent capacitance is how much? C equivalent is equal to how much? Whenever C1, C2, C3 are connected in parallel, C1, C2, C3 are connected in parallel, then equivalent capacitance formula is C1 plus C2 plus C3. So when R1, R2, R3 connected in parallel, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. But here capacitance series connection formula opposite to resistor series connection formula. So here parallel connection means C1 plus C2 plus C3. So what is the answer? 2 plus 4 plus 8. So 14 microfarad. So this is a C equivalent. Equivalent capacitance or total capacitance or effective capacitance is 14 microfarad. Answer is C. Next question about the four capacitors again. 4 capacitors each of 10 microfarad. Again here you see equal capacitors. So how many capacitors are there? N is equal to 4 capacitors. And that each capacitance value is how much? 20 microfarad. Or how they are connected? They are connected in parallel. Then what is the total capacitance value? Then whenever capacitors are connected in parallel, then total capacitance formula C equivalent is equal to C1 plus C2 plus C3 plus C4. So here is equal to C1 is 20, C2 is also 20, C3 is also 20, C4 is also 20. So what is the answer? 80 microfarad. Simply what I can write, whenever equal capacitors are connected in parallel, the total capacitance value is N into C. N is how many capacitors? 4. C is equal to 20 microfarad, that is 80 microfarad. So answer is A, 80 microfarad. Next, 11th question. 10 capacitors each of 10 microfarad. How many capacitors? 10 capacitors. Each capacitance value is how much? 10 microfarad. How they are connected? They are connected in series. So they are connected in series. Then what is the combined capacitance formula? So for the series connection of capacitors, what is the formula? 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus and so on. But here we have one small formula whenever equal capacitors are connected. So what is the formula? Combined capacitance. Combined capacitance is equal to C divided by N. What is the C value? 10 microfarad. What is the N value? How many number of equal capacitors connected? 10. So what is the answer? We will get as 1 microfarad. Combined capacitance or total capacitance is how much? 1 microfarad. Answer is B. Next question, that is question number 12. A star arrangement. The symbol represents a star connection, or it is also called as T connection. A star arrangement of resistances, each has resistance of 3 ohm. The equivalent delta arrangement will be how much? So before going to solve this question, little we will discuss about the star connection and delta connection. So the star to delta conversion and delta to star conversion is used in the reduction of the circuit, simplification of the circuit. So whenever we want to reduce these two resistors are connected in series, these two resistors are connected in parallel, to analyze it whenever it is becoming difficult, then we will we will transform, if any star connection is there, that will transform into delta connection. If any delta connection is there, we will transform into star connection. So first of all, how to convert star into delta, delta into star, what are the formulas, we will see. Let us say this is the star connection. Let us say this is the terminal B and it is terminal A, and here one more resistor terminal, this is RB and it is RA, and this resistor is RC which is connected to C. This star connection is there in one network, but because of the star connection I am unable to reduce the circuit simply. I am unable to analyze which are connected in series, which are connected in parallel, because of the star connection present in the circuit. Then what I will do, I will replace the star connection with the equivalent delta connection. How I am doing, carefully observe. These terminals are not changing, they are A and B and C. You see here, this RA and RC combination which is connected between A and C. So between A and C, that I am calling as RAC. This RAC came because of this combination. Understood? Next, because of this RA and RB combination, which should be connected between A comma B terminals, which should be connected between A comma B terminal, this I am calling as RAB. Next, one more combination, because of this RB and RC which is connected between B terminal and C terminal, which should be connected between B terminal and C terminal, that I am calling as RBC. Now did you observe, we have replaced the star network with the equivalent delta network. Then what is the RAB value, what is the RBC value, what is the RAC value, we have to find out. We have a derivation for that. Here I am writing the formula directly. I am writing RAB formula. This RAB is coming because of what and what resistor? RA resistor and RB resistor. This RAB came due to RA and RB. Then simply what I will write? RA plus RB plus RA into RB by third resistor. What is the third resistor? RC. This is the third resistor. So RAB is equal to RA plus RB plus RA into RB by RC. Next I want the formula of RBC. RBC. You see the RBC between B and C, it came because of between B and C, RB and RC. So this RBC came because of this RB and RC. So RBC is equal to simply you write this resistance plus this into this by third resistance RA. RB plus RC plus RB into RC divided by third resistor RA. Similarly, I want to write the formula for RAC. This RAC came because of this RA and RC. So I will write RAC is equal to RA plus RC plus RA into RC divided by RB. Right? You understood the formula? So whenever I change the star network into delta network, T network into pi network, star is also called as T network, this delta is also called as pi network. These are the formulas. Now let us see how to transform delta network into star network. Let us understand how to change delta network into star network. Now see, this is the terminal A. This is a terminal A. This is a terminal B. And it is a terminal C. Between A and B one resistor. Between B and C one resistor. Between A comma C one more resistor. Between A comma B I am calling as this RAB. Between B comma C I am calling as RBC. Between A comma C I am calling as RAC. This is the delta network. We also call as pi network. So why I am calling this network as pi network means, you see, I can write this network like this. Yes or no? It is looking like pi or not? Reversal of pi or not? This delta network is there in the circuit, one big complex circuit, but because of presence of this delta network I am unable to reduce the circuit further in a simplified manner. Then what I'll be doing, I am replacing or transforming this delta network into its equivalent star network. Now let us see how to change this delta network into star network. Again terminals are there, this is A terminal and this is B terminal, this is C terminal, this is A and it is B and it is C. See, this RAB RAC combination, RAC combination is connected to which terminal? A terminal. So because of these two resistors RAB and RAC, one resistor is coming that is connected to which terminal? A. That's the reason I am calling as what? RA. This RA came because of two resistors. What are they? RAB comma RAC. This RA came because of these two resistors. Those two resistors connected to one common point, that is what? A. That's the reason I have connected to common point A, and its name I am calling as what? RA. And next you see RAB and RBC both are connected to one common point B. So one resistor I am connecting to one common point B. It came because of RAB and RBC. That's the reason I am calling this as what? RB. Next, the resultant of RAC and RBC is connected to which terminal? C terminal. So to the C terminal, one more resistor I have connected, that I am calling as RC. This RC came because of this RBC and RAC. Right? You understood now? This delta network I have replaced with its equivalent star network. No change in the terminals. You observe A terminal, B terminal, C terminal. They are present like that only. A terminal, B terminal, C terminal. Now, what is the RA value in terms of RAB, RAC, RBC? What is the RB value? What is the RC value? I know these three values in the network, but I am replacing with this new resistors. That new resistor values I want to find out. You see, RA formula I am writing here. RA came due to what and what resistor? RAB and RAC. This resistor value RA is equal to this into this divided by this plus this plus this. It means RA is equal to RAB into RAC by RAB plus RAC plus RBC. And RB, this value is equal to, this came due to these two resistors. RB is equal to RAB into RBC by RAB plus RBC plus RAC. And this RC came due to RAC and RBC. Therefore, this RC is equal to RAC into RBC by whole divided by RAC plus RBC plus RAB. So, one I'll write the formula, then you will understand very clearly. See, this is the delta network RAB, which is connected between A and B. This is RAC and it is RBC. I am transforming these two resistors RAB, RAC. Resultant is RA, which is connected to terminal A. And this RA value I want. RA is equal to, this RA is equal to this into this. RAB into RAC whole divided by RAB plus RAC plus RBC. RAB plus RBC plus RAC. Similarly, resultant of RAC RBC connected to C, that is RC connected to C. This RC value came due to RAC and RBC. Therefore, RC is equal to this RAC into RBC whole divided by, again denominator remains same in all the resistors, that I am calling as sigma RAB. Sigma RAB means RAB plus RBC plus RAC. So these are the formulas when we transform delta network into star network. One simple example we'll take and we'll understand. Let us take one small example. Let us say this is 1 ohm, this is 1 ohm, and this is 1 ohm. But I want equivalent delta network. This is delta, this is delta network resistance. Now this value I want. This value came because of this 1 ohm and this 1 ohm. So this resistance value is equal to this plus this, 1 plus 1 plus 1 into 1 by third resistor, 1 into 1 by 1. So what is the value? 3. And this resistor came because of these two resistors. So how I'll get this resistor value plus this resistor value, 1 plus 1 plus this into this, 1 into 1 divided by third resistance value, 1. This is also 3 ohm. And this resistor came because of these two 1 ohms. So 1 plus 1, 1 plus 1 plus 1 into 1, this into this divided by third resistor 1, that is equal to what? 3 ohm. You observe carefully. 1 ohm, 1 ohm, 1 ohm. 1, 1, 1 in star network. They became 3, 3, 3 in delta network. One thing you carefully observe, when equal resistors are connected in star network, when they are transformed into delta network, answer is becoming 3 times. So 1 into 3, 1 into 3, 1 into 3. So then if you say 2 comma 2 comma 2 in star network, they become 3 times in the delta network. 3 into 2, that is 6 comma 6 comma 6. This is applicable whenever equal resistors are connected in star. This is star to delta. You observe star to delta, value is increasing. 1 1 1, value became 3 3 3. Now let us see delta connection. Delta to star. Let us say this is delta connection. Now this is 1 ohm, again this is 1 ohm, this is also 1 ohm. So this is A, B, C. Now these two resistors resultant is this one, this is A. These two resistors resistance is this one, this is B, and these two resistors is connected to what? C. This is B and nothing but what? It is C. I want RA value, I want RB value, I want RC value. You see, this RA is a resultant of this 1 ohm and this 1 ohm. Then what is the RA formula? I told RA is equal to this into this divided by 1 into 1 divided by 1 plus 1 plus 1, 1 plus 1 plus 1. So what is the answer? 1 by 3. Now RB value is equal to this into this, 1 into 1 whole divided by 1 plus 1 plus 1 is, it is what? 3. Again 1 by 3. RC value, this RC value came because of this 1 ohm and this 1 ohm. So 1 into 1, this into this, 1 into 1 divided by 1 plus 1 plus 1. It became what? 1 by 3. Did you observe 1 comma 1 comma 1 in delta network? Whenever equal resistors are connected in delta, they are becoming 1 by 3, 1 by 3, 1 by 3 in the star network. So when I am transforming delta into star, the value is reducing. 1 1 1 is becoming 1 by 3, 1 by 3, 1 by 3. So whenever you are getting any confusion, you remember that delta is closed network. Delta is closed network, strong network. Delta is like this, closed, strong, more value. And star network is open, T network is open, so open, less value. So more value 1 1 1, less value 1 by 3, 1 by 3, 1 by 3. Like that you remember, whenever you are changing from delta to star, the values are going to decrease. When you are changing from star to delta, the values are going to increase. So this is a brief introduction about star to delta and delta to star conversion. So remember, only whenever equal resistors are connected in delta, then whenever they are transforming into star, they are becoming by 3. A comma A comma A comma A in delta network, they become A by 3, A by 3, A by 3 in the star network. So remember that A comma A comma A in star, they become 3A 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 in the delta network. Whenever equal resistors are connected in star or delta, these formulas are going to be used. Now let us come back to our question now. So what is the question number 12? When star arrangement of resistances, now resistors are connected in star, each value is how much? So this is 3 ohm, this is 3 ohm, this is 3 ohm. Equivalent delta arrangement. So what is the equivalent delta arrangement we want to? So star transformer to delta and equal resistance, whenever equal resistance are said, they become 3 times, 3 into 3, 3 into 3, 3 into 3. So they become what? 9 comma 9 comma 9. So delta network, each resistor value becomes what? 9 comma 9 comma 9. So answer is A. Whenever 9 comma 9 comma 9 connected in delta, they become by 3, 9 by 3, 9 by 3, 9 by 3, that means 3 in the star network. Clear? Next, RA equal to RB equal to RC equal to R in star network. So this is star network or T network. So this is R, this is R, this is R. Let us say this is RA and it is RB and it is RC. RA is equal to R, RB is equal to R, RC is equal to R. Then RAB equal to RBC equal to RCC equal to in the equivalent delta network. Again same thing, when star is converted into delta, this is A and it is B and it is C. AC, sorry, this is C and this is nothing but what? B. AC resultant is R AC. AB resultant is this is R AB. CB resultant is this is RBC or RCB. Now R comma R comma R, equal resistors are there in star. When converted into delta, they become 3 times. So they become 3R. So answer is what? 3R. B. Star to delta, R is becoming 3R. Value is increasing. Star, open network, like that you remember, just for the sake of understanding, remembering. Star, weak network, delta, strong network, more value. R is small, 3R is more, like that. Next, question number 14th. 3 resistances, each of R ohm, are connected in delta. Now each resistor R, this is delta, and their equivalent star value for each resistance. So this star value I want. So R comma R comma R, equal resistors in delta, they become by 1 by third, they become 1 by third of R, this value R. So 1 by third of R, 1 by third of R, that is R by 3. R comma R in the delta network, they become R by 3, R by 3, R by 3 in the equivalent star network. Next, 15th question. The value of resistance in the delta connection is 3 ohms. So the value of resistance in the delta connection is 3 ohm. So this is 3 ohm and it's equivalent in the star connection. So it's equivalent in the star connection 1 by third of 3, that is equal to 3 ohm. Here we are assuming all the resistors are 3 ohm in the delta, they become 1 by third of 3, that is 1 ohm in the star connection. Answer is B. Next is 16th question. 3 resistor value of R ohm, each are connected in star. Now R in the star. Equivalent delta will comprise of 3 resistance. In the delta, they become 3 times of this resistance. So 3R, this is 3R, and this is also 3R, and this is also 3R. So they become 3R each. Answer is B. Next, 17th question. 2 resistors each of 4 ohm and 12 ohm are connected in parallel, and parallel combination is connected in series with the 2 ohm. You see here, carefully observe. 4 ohm, this is a 4 ohm, and 12 ohm, this is a 12 ohm. both are connected in parallel, and the parallel combination is connected in series with the 2 ohm. It is in series with the 2 ohm. If this circuit is connected across 100 volt supply, this circuit I am connecting across 100 volt supply, this is 100 volts. Then what is the total current drawn? So total current, and remember, total current drawn we want to calculate means it is a current supplied by this particular source. This I value we want to calculate. So I value, this I value means it is a total current. So total current is equal to voltage divided by total resistance. So total resistance means these entire three resistors we should replace with the single resistors that should be connected with the 100 volts. Like this I should get, this is the 100 volts, and I should get one total, this is called total resistance. So only one resistor should remain with the 100 volts battery terminals. So 100 volts battery terminal is on the left hand side, I am starting on the right hand side. So I am going from right hand side to left hand side to calculate this total resistance. You see, when I am coming from right hand side to left hand side towards the battery, 12 ohm and 4 ohm, how they are connected? 12 ohm first and 4 ohm first end connected to one common point. 12 ohm second and 4 ohm second end connected to other common point. This connection is known as parallel connection. Let us say some current is coming, it is dividing into two parts. Current is dividing means these two are connected in parallel. 4 ohm is in parallel with the 12 ohm. So that is equal to 4 into 12 divided by 4 plus 12. 4 into 12 is 48. 48 by 16, that is 3 ohm. So this 4 ohm and 12 ohm, they are replaced with how much resistance now? 3 ohm. You see, these two resistors, 3 ohm, 4 ohm, 12 ohm first end, this is a first end. 4 ohm, 12 ohm parallel combination second end, this is a second end. So this 4 ohm, 12 ohm first end is connected to 2 ohm, 2 ohm second end, this is 2 ohm, 2 ohm second end. And 4 ohm 12 ohm second end 4 ohm 12 ohm parallel combination second end is connected to battery negative terminal. So it is connected to battery, this is plus and it is minus, and this is 100 volts. Now this current is nothing but what? I. Now you can simply calculate, this is 100 volts. So this I is equal to what is the value, what is the voltage? 100. Now what is the total resistance? Now 2 ohm and 3 ohm both are connected in series, 2 plus 3, so 5. So 520 is. So what is the total current I value? 20 ohms. What is the total resistance here? 2 ohm and 3 ohm both are connected in series, that is 5. So 20 amps. Total current drawn, current going out of this battery, total current drawn by the circuit I is equal to how much? It is 20 amp. Answer is C. Next question. Two resistances, you see here how many resistance? Two resistances, each of 10 ohm and 20 ohm are connected in parallel across a DC voltage source. You see how they are connected? This is the DC voltage source, plus minus, I am calling DC voltage source, voltage value is V, and 10 ohm and 20 ohm are connected in parallel. So this is the 10 ohm resistor and it is the 20 ohm resistor. Both are connected in parallel across the supply, means across the battery, means parallel connection. The current to through the 10 ohm. So this current I want, the current to through the 10 ohm I10 I am calling, current to through the 20 ohm I am calling as I20. This current coming from the battery, this I am calling as total current I. But I want current through the 10 ohm I10 value. I10 I want, you see, in terms of current flowing through the 20 ohm or in terms of current flowing through total current, I want to develop the relation between I10 and I20 I want. First I'll calculate the current through the 10 ohm. So current through the 10 ohm I10 is equal to, we have one current division formula. So what is that current division formula? Is total current which is causing the I10. This I10 is coming from where? This total current I. So this I is dividing into two parts, I10 and I20. For I10, what is the total current I? So this is the total current into opposite resistance. Opposite resistance means in which resistor we are calculating the current to 10 ohm. To the 10 ohm, what is the parallel branch resistance? What is the parallel branch resistance? To the 10 ohm, parallel branch resistance is what is the parallel branch resistance? 20 ohm. So opposite resistance is what? 20 whole divided by sum of resistances of the branches which are connected in parallel. 20 ohm and 10 ohm both are connected in parallel. Sum of those resistances 20 ohm plus 10 ohm. So what is the value? 20 by 30 into I. So 20 by 30 into I, nothing but what? What is this value? I10, current through the 10 ohm is equal to 2 by 3rd into I. Let us say this is equation number A, or you call as equation number 1. Next, I'll calculate I20, current through the 20 ohms. So current to through the 20 ohms. So again, total current into opposite resistance divided by sum of resistance in parallel. So current through the 20 ohm. This current through the 20 ohm, I20 is coming from where? For I20, who is the father? For I20, who is the total current? It is I. So this is I, total current into opposite resistance. Opposite resistance means we are calculating the current through the 20 ohm. To the 20 ohm, what is the parallel resistance? 10 ohm. So opposite resistance is 10 ohm. Here this is the opposite parallel branch resistance divided by sum of resistances 10 plus 20 again. So 10 by 30. So 1 by 3rd into I. Let us say this is equation number 2. But I want relation between I10 and I20 because the current through the 10 ohm I am assuming as I10, current through the 20 ohm I am assuming as what? I20. So I10 is equal to, what is the equation? 2 by 3rd into I. So from this equation, I20 is equal to I by 3. From this, what I can write? I is equal to what I can write? This 3 becomes here 3 into I20. So here I10 is equal to what? 2 by 3 into I value. 2 by 3 into this I. This I am taking from here. 3 into I20. 3 into I20. This 3 cancel. I10 is equal to 2 times I20. So current through the 10 ohm is equal to 2 times current through the 20. So that means 2 times means if I want to convert into percentage into 100, I have to multiply. 2 into 100 is nothing but what? 200%. Current through the 10 ohm is equal to 200% of the current through the 20 ohm. So normally it is 2, but if you want to convert in terms of percentage, you multiply it with 100, 200%. Answer is what? D, 200%. Here the main formula what I have used here is current to division formula. Here we call this formula as current division formula. Whenever things are connected in parallel, whenever current is dividing, we use the current division formula. You see here, this is a total current I. It is dividing into two parts. Let us say it is RA and it is RB, and I want I1, I want I2. So what is the current division formula? I1 is equal to total current into opposite resistance divided by sum of resistances in parallel. Here you see total current for I1. What is the total current? I into opposite resistance. We are calculating current through RA. In parallel with the RA, what is there? Only RB is there. Here I'll write RB. Let us say here one more resistor is there, that is RC. Now how RC and RB are connected? Series. Then opposite resistance not only RB, it is a series combination of RB and RC. Then it becomes what? RB plus RC whole divided by RA plus RB plus RC. these two branches total sum of resistances Ra plus Rb plus Rc. So this is a current division formula, very important formula. Next question, 19th question. Three resistors 4 ohm, 6 ohm, 8 ohm are connected in parallel. In which resistor power spent is maximum? So how they are connected? They are connected in parallel. So remember, whenever resistors are connected in parallel, whenever resistors are connected in parallel connection, voltage is going to be same. Let us say this is R1, this is R2, and this is R3. Three resistors are connected in parallel with a supply voltage V. Then voltage across R1, voltage across R2, voltage across R3 is same. That voltage is nothing but what? V. So 4 ohm, 6 ohm, 8 ohm, they are connected in parallel. So voltage across 4 ohm, voltage across 6 ohm, voltage across 8 ohm is going to be same, that is voltage is same. Then in which resistor the power is going to be maximum, we need to calculate. So so in which resistor power spent is maximum, we need to find. What is a power what is a power spent formula? P is equal to V square by R. As voltage is same in all the resistors, V is same, then P is directly proportional to 1 by R. It means if the resistance value is small, then power spent will be maximum. So which resistor is small? In that resistor maximum power will be spent. So 4 ohm, 6 ohm, 8 ohm. So as the 4 ohm is less among all the three resistors, the power spent in the 4 ohm is going to be maximum, because as the voltage is same, then power spent is inversely proportional to the resistance. Small resistance, more power spent. 4 ohm is a small, so in the 4 ohm maximum power will be spent. So answer is 4 ohm A. Now let us see few fill in the blanks questions. So first question, in series combination, what is a C equivalent? What is the equivalent capacitance? So C equivalent is equal to, what is the formula? C1 plus C2 plus C3 and plus on so on plus Cn. This is a in series combination, always remember, resistors means R1 plus R2 plus R3, but in capacitor it is opposite to the resistors. So in series combination, C equivalent we have to calculate means 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus and so on, and only two capacitors are connected, then C equivalent is equal to C1 C2 divided by C1 plus C2. This is a equivalent capacitance formula when they are connected in series. Next, second question, when two resistors are in parallel, what is the equivalent resistance? When two resistors are in parallel, R equivalent is equal to R1 R2 divided by R1 plus R2. Next, third question, when resistors are connected in parallel, the voltage across all the resistances, see in parallel connection voltage is going to be same and current will be divided. Let us say this is a battery and here some three resistors are connected, R1, R2, R3. So as R1 first and R2 first and R3 first, all the three first ends are connected to battery positive terminal. R1 second end, R2 second end, R3 second end, all the three resistors second ends are connected to battery's negative terminal. So three resistors first end at one common point, three resistors second at other common point. This connection is known as parallel connection. See, between R1 first end, R1 second end, what is the potential difference? Potential difference between positive terminal and negative terminal, let us say it is V. So voltage across R1 is going to be V. What is the voltage across R2? R2 first and positive terminal, R2 second and negative terminal. Between positive and negative, what is the voltage? Again V. Voltage across R3 is also V. So in parallel connection, voltage across R1, voltage across R2, voltage across R3 is same. So in parallel, voltage across all the resistances is same. Next, fourth question, four resistors each of resistance R ohm are available, then minimum resistance of the combination will be. So to get the minimum resistance, resistors should be connected in parallel. So when 4 resistors, so that means N is equal to 4, and each resistance value is how much? R. Then parallel combination, we know one formula, total resistance is equal to R by N. So R means what is the value? R I am taking, and number of resistance are what? 4. R by 4. The minimum resistance of the combination will be R by 4. So when we will get the minimum resistance? When all the resistors are connected in parallel, we will get the minimum resistance. Thank you. This is the second lecture in basic electrical engineering subject, first mid bit paper previous year questions. So in the next lecture, I will be discussing network theorems related previous bit paper questions and solutions. That is a last topic in the network analysis. So if you missed the first lecture, I'll provide that first lecture link in the description. You also finish the first lecture. Thank you.